Welcome to Okonko Academy. So in this tutorial, we are going to be talking about solutions of first order differential equations. So first of all, I'd like to recommend that if you are new to this channel, you subscribe this channel, then also like our videos, and also put us to post notification so that you always be notified for every video posted. Now let's start with testing for solution. So in differential equations, we have two kinds of solutions. We have the general solution, then the actual or the particular solution. But in this tutorial, we are going to talk about steps in proving that a given statement is a solution to a differential equation. So first of all, I would like to explain some few things. See, in this tutorial, you'll be seeing me using y prime and y prime prime. So the dy dx is the same as y prime, and the squared y dx squared with the second differential of y with respect to x the same as y prime prime. So now let's go through the first example. Now in the first example, we are saying that we should prove that a function which is y is equal to e exponent negative x plus sine x is a solution of this differential equation, which is y prime prime plus y is equal to 2e exponent negative x. So now how do we go about this? So now first of all, for us to solve this equation, we first need to note the differential in the differential equation. So we have the differential here to be a second order. So therefore it means that we are going to differentiate our function twice. That is, the function we've been given, y equals e exponent negative x plus sine x. So now let's proceed. Now let's find the first differential for the equation. Now our y prime is going to be, if we differentiate e exponent negative x, I hope you remember from calculus that if we differentiate e exponent negative x, we are just going to differentiate the exponent, which is negative x, to get negative 1, then multiply it by the actual function itself, which is exponent negative x, getting negative e exponent negative x. So now having gotten that, let's differentiate sine x. Now if we differentiate sine x, we are going to get what? Cos x. Okay, now because this is a second order differential, we need to differentiate it again. Now let's find the second differential of the function. Now let's differentiate e exponent negative x again. If we differentiate that negative e exponent negative x, we are going to end up getting e exponent negative x. Why? Because we already have negative in front of the e exponent negative x. And if we differentiate e exponent negative x, as I said earlier on, we are going to get negative e exponent negative x. So the negative is going to nullify the negative already in front of the function, which is going to make it what? Positive. Right, so now we are going to get e exponent negative x. Now if we differentiate cos x, we are going to get negative sine x. Now after getting your two equations, you will just substitute into the general equation, which is y prime prime plus y is equal to 2e exponent negative x. So that is, wherever we see y prime prime, we are going to substitute the expression y e exponent negative x minus sine x, and wherever we see y, we are going to substitute it with the expression y equals e exponent negative x plus sine x. So now let's proceed. So we have e exponent negative x minus sine x plus, so our y is giving us what? E exponent negative x plus sine x, which is equal to 2e exponent negative x. So now, having stated that, we could see that negative sine x is going to cancel positive sine x. Then e exponent negative x plus e exponent negative x is going to give you 2e exponent negative x is equal to 2e exponent negative x. So now, having stated that, we could see that our left hand side is equal to our right hand side, which implies the equation, which is y equals e exponent negative x plus sine x. It's actually a solution to the expression y prime prime plus y is equal to 2e negative x. Now, what if we had something like 3e exponent negative x? We could see that our 3e exponent negative x is not equal to 2e exponent negative x. So now, in this case, we are going to say that the equation is not a solution to our differential equation. Now, let's move to the second example. So now, with our understanding from the second example, we have to prove that the function y equals e exponent x minus e exponent negative x is a solution of the differential equation y prime is equal to y plus 2e exponent negative x. So now, with the idea from here, with our differential equation, it's a first order differential equation. So now it means that we are going to differentiate the equation only once. See, with the previous example, it was a second order. So now we differentiated twice. But with this example 2, it's a first order. So I'm going to differentiate only one. So now let's differentiate. So now we are going to get our y prime to be equal to. Now, if we differentiate e exponent x, we are going to get e exponent x. Why? Because I stated earlier on that whenever we differentiate an exponential function, we first differentiate the exponent, then we multiply the result with the initial function. So now our function here is e exponent x, and the exponent is x. Now, if we differentiate x, we are going to get 1. Now, 1 times e exponent x, we are going to get back our e exponent x. Now, we already have negative here. Let's differentiate e exponent negative x. So now with this one too, we are going to differentiate the exponent first, which is negative x, to get negative 1. Then multiply by the function. So now our resulting function is going to be minus e exponent negative x. So now we are going to get our y prime is equal to e exponent x plus e exponent negative x. So you would ask yourself, why is it plus? So you could see that we already have a negative there. Then in the brackets, we also have a negative e exponent negative x. So the negative is going to nullify any negative there, making it positive. Okay. So now, having gotten that, we already have our general solution to be y prime is equal to y plus 2e exponent negative x. So now, wherever we see y prime, we are going to substitute e exponent x plus e exponent negative x. Okay. And wherever we see y, we are going to substitute our function, which is e exponent x minus e exponent negative x plus 2e exponent x. So now let's rearrange. We already have e exponent x plus e exponent negative x. So now when e exponent x crosses the equal sign, we know we are going to get negative e exponent x. And when negative e exponent negative x crosses the equal sign, we are going to get positive e exponent negative x. So that's equal to our 2e exponent negative x. So now we could see that e exponent x is going to cancel negative e exponent x. Now we have e exponent negative x plus e exponent x, giving us 2e exponent negative x being equal to 2e exponent negative x. So now you could see that here too, our left hand side is equal to our right hand side. So now, since our left hand side is equal to our right hand side, we can conclude that y indeed is a solution to our differential equation. So now, what if we had negative 2e exponent negative x is equal to 2e exponent negative x? So now you can all see that one is negative, one is positive, so they never be the same. Now because here they are never the same, we conclude that our equation is not a solution. Alright. So now let's consider the third equation, which I will urge all of you to solve it yourself. So now we have the solution of y equals 2e exponent negative x plus x exponent negative x. So this is a solution to y prime prime plus 2y prime plus y is equal to 0. So I will urge all of you to try this on your own. Thank you.